In this situation, we have got a particle and it's being acted on by three forces, and the one going to the left is 3 newtons, so add this onto your diagram in your pack. That's at 40 degrees, and one's at 20 degrees, and that one is 4 newtons, and then it's got 5 newtons going down. And we're interested in the resultant force, so that's what all of them together, what does the particle feel all together? So one of the ways of thinking about this is to break the components up into their components, basically I and J components. So for example, this 3 Newton force here, this is at 40 degrees, we've got 3 cosine 40 here and 3 sine 40 here. So we can break it up into the particle feeling push upwards or a pull upwards, 3 sine 40, and 1 to the left, 3 cos 40. Similarly, pull to the right with a force of 4 cosine 20, and pulled up with a force of 4 sine 20, and then down obviously with the 5. So we have got, in terms of up and down, that's the sort of I part, we've got 3 sine 40 and 4 sine 20 minus, minus 5, because that's going in the opposite direction, so I'm taking this way to be positive for the J's. J is up and down. And then also left and right, so that's the I's. We've got minus 3 cos 40 and 4 cos 20. So getting my calculator and working out what those actual numbers are, making sure I'm in degrees, I get 1.46i minus 1.7j. So that's the overall feel that the particle has, all these forces acting on it, these 3 forces, and altogether it's 1.46i minus. So it sort of feels a pull roughly in that direction there. Now we're asked what is the magnitude of the resultant force and the angle that it makes. And we know that it's going across 1.46 and down 1.7. So the magnitude we can get using Pythagoras, 1.46 squared plus 1.7 squared square rooted is the magnitude. You can work that out yourself, can't be bothered. And the angle here, theta, well, tan theta is equal to 1.7 over 1.46. So if we just get a calculator and work out what that is, and then inverse tan it, we get 49.3 degrees. And that is, usually we write that because it's going below the x-axis, we'd write it as the angle being negative, so minus 49.3, meaning that it's going that way rather than going that way. So now we've got a force of magnitude 8 newtons and another one at an angle 60 degrees. It's not very good 60 degrees, I haven't drawn that very well, never mind. 60 degrees, but we don't know how big it is. But it does tell us that the magnitude of the resultant force is root 97. Now we could do a similar thing to the last example and break it into components, but there's another way of thinking about it. A resultant force is what you get when you apply both forces, and vectors can be added geometrically by putting one on the end of the other one. So instead of having the x here, we could draw it here, coming out of the end of this force. So you're saying I'm doing this one and this one, and this is where we'll end up. That's the resultant force over there. So if I draw it like that, we've got 8 across, then we're going off at this angle. This is a length of x, and this angle here was 60, so this angle here is 120, and the resultant force is where you end up, the result of the two, that one there, and we're told that that has a length, magnitude, root 97. Now I hope you can see that using this way of thinking about it, with vector sums, we put the vector on the end of each other, if there's only 2, then what that gets you is a triangle, and hopefully we can use the cosine rule to solve this. So the opposite side, that's root 97 squared, is 8 squared plus x squared minus 2, 8x cosine 120. So that gives us 97 is 64 plus x squared minus 16x times cosine 120, which is minus a half. Then we can organise this a bit more nicely, I think, by putting everything on the right. We've got x squared plus 8x minus, probably not working, what's 97 minus 64, minus 33 equals 0. And then solving that quadratic gives us, I think I can factorise it. X minus 3, I think that works. X is 3 or x is minus 11, but x was a magnitude, so it can't be negative, so x is 3 newtons. So there's your two ways of thinking about it. Sometimes with only two forces, it helps to think of them in terms of resultant vectors, put one on the end of the other, use the cosine rule, maybe the sine rule, normal geometry, and the other way, when you've got more than two vectors, or your vectors are given in terms of, your forces, sorry, given in terms of vectors, is to treat it like a vector sum, how many i's and how many j's, and that will give you the resultant vector, the resultant force.